In this lesson, we'll go over the equation of a parabola. To start with, I graphed the equation y is equal to x squared over 16 in Desmos, and I got this graph that opens up here. It's a quadratic. And this is an example of something that is a parabola. So again, the one that I have here is opening upwards. A parabola could also open downward and also possibly to the right or to the left. It just depends on the way the equation is written. So for starters, let's look at a more precise definition of a parabola. So a parabola is the set of all points that are equidistant from a fixed line called the directrix and a fixed point called the focus, which is not on that line. For this equation, I'll state what the directrix is and also what the focus is. The directrix is going to be the line y is equal to -4. So I'll graph that on here like this. This thing is the directrix. And the focus is the point 0, 4, this thing here. If you start with a given directrix and a given focus, and you want to create the parabola, you find all points that are an equal distance from here, then to here. So for example, like the distance from the focus to this point is equal to the distance from this point down to here, and that's why this point is actually on the parabola itself. Or likewise, if you draw a line going from here over to this point, that distance is equal to the distance from here down to the line. And the same thing happens over on the other side of the equation as well. So the distance from here to here is equal to the distance from here down to here. You take all those points together and you get this shape. And here's another point, this point. This is a distance from 4 from the focus and also from the directrix. So the question is going to be, if you're given a particular parabola, how do you find the focus and how do you find the directrix? And we'll talk about that in the next slide. There are two possibilities when graphing a parabola, one that could either open upward or downward or to the right and then to the left. The standard form for these equations are 4 times p times x is equal to y squared, or 4 times p times y is equal to x squared. So like if you solve this for y, you'd have x squared over 4p. And this is kind of a lot like the one we had on the previous slide where, oh, since it's y is equal to an x squared, it opened upward. Here, since x is equal to y squared, this is why it opens either to the right or to the left in the x direction. Writing the equation in this form is nice because p, this value here, tells you the location of the focus and the directrix. That is, this point here is the focus, and its coordinates are p, 0. So if you can write your equation in this form, that number p tells you how far you go from here, which is the vertex, to here, the focus. So let me label this here. 0, 0 is the vertex, and the point p, 0 is the focus. How do you get the equation of the directrix? Well, the distance from here to here is equal to the distance from here to here. So this x value is at -p. In fact, that is the equation of this line. So for the directrix, the equation is x is equal to -p. And it's very similar to our equation if it's written as y in terms of a function of x. That is, this point is the focus, but now it's on the y-axis instead of the x-axis. So that point for the focus is given by 0, p. So the vertex is still 0, 0. That didn't change. But the point 0, p is the focus. Now the directrix, this time it's a horizontal line. It'll be a distance of p going downward, so it's at -p. In fact, the equation y is equal to -p is the directrix. So that's it. Essentially, if you're given a parabola and you can write it like this or write it like this, you'll be able to identify the focus and the directrix. Essentially, you're looking for what the number p must be equal to. Before going over a specific example, I thought it might be nice to actually try to derive the equation of a parabola. That is, if your focus is at the point p, 0, and the directrix is x is equal to -p, why does the equation have to look like 4 times p times x is equal to y squared? So here I'm specifically focusing on the one that opens in the x direction. So the equation would look like this. Like, where does this come from? The idea is, if you draw a line that goes from here, the focus, to let's say this point, which I'll call x comma y, I'll call that distance d1. By definition, it must be equal to the distance from the directrix to this point. And I'll call that d2. The definition of the parabola said that the distance d1 must be equal to the distance d2. Well, what are these distances? We can use the distance formula to actually construct or figure out what the length of this line segment is, and this one as well. Let's start by figuring out the distance d1. So I have some point x comma y and the focus, which is p comma 0. The distance formula says that you take the difference of the x coordinates and square it, you add that to the difference of the y coordinates and square it, and then you take the square root of that entire expression. So d1, the distance, is really equal to the square root of, okay, I'm going to take the difference of the x coordinates, that's x minus p, and then you square it, and then you add on the difference of the y values, so it's y minus 0, and then you square it, and then you take the square root of that whole thing. That has to be equal to d2, the distance between these 2 points. So let's figure that out. Okay, we're still using the distance formula, but I need coordinates for this point. Well, I know the x coordinate is going to be negative p, and the y coordinate is going to be the same as this y coordinate here because that's supposed to be a horizontal line, so we get the same y value. So I have both coordinates. I know the x's and the y's. So what I'll do is take the difference of the x values, so that's x minus a minus p, and I square it. I then add on the difference of the y values, which is y minus y, and I square that, and I take the square root of this whole thing. I'm noticing immediately that, well, I can actually square both sides and cancel the square roots. So like, why not do that? I'm going to square both sides. This gives us x minus p squared plus y minus 0 squared is equal to x plus p squared plus y minus y squared. If I'm looking to simplify some stuff, y minus 0 is just y. So this thing here is y squared. So we get x minus p squared plus y squared is equal to, okay, this is x plus p squared, and then, well, y minus y is 0, and if you square to 0, that's equal to 0, so we're done. We don't have to write anything else. I think what I'll do next is square this out and square this out. If you square x minus p, you get x squared. Negative p squared is a positive p squared, but you get 2 middle terms. You get minus 2xp. So you have to FOIL this out. So you get x times negative p, but you get 2 of them. I'll add on this y squared, and that's equal to whatever I get if I square this thing out. You get x squared. You also get p squared, but again, you get 2 middle terms. You get an xp, and then you get a second one, so you get 2xp. All right, I'm noticing that I can cancel x squared from both sides of the equation. Oh, I can also cancel p squared. And what we're left with is negative 2xp plus y squared is equal to 2xp. I see one step left, and that is to add 2xp to both sides of the equation. And we end up with y squared is equal to 4 times x times p. And if I just rearrange this a little bit, I'll put the 4xp on the left, but I'll just reverse it and say, okay, it's 4p times x is equal to y squared, and we got it. So that's how you can actually derive this equation. You set up a picture, label the directrix and the focus, set two distances equal to each other, and go from there. Okay, so let's apply this in example 1. Find the focus and the directrix of the following parabola, and which way does the graph open? So to start with, I'm seeing this as an x is equaling a y squared. So I'm going to say, okay, maybe I'll write it as, I know it's a 4 times p times x is equal to y squared. So there's two options for your graph. It's either going to open to the right or it's going to open to the left. And that depends on where the focus is. So let's find that. Where is the focus of this thing? What we're going to do is take the 24x and make it look more like this, 4 times p times x. Our goal is to find what the value of p is equal to. Basically what we're saying is 4px is equal to 24x. Or, more simply, 4p is equal to 24. If you divide both sides by 4, you get that p is equal to 6. Okay, this means that the focus is at the point 6, 0. So that is 1, 2, 3, 4, 5, 6. It's like right about there. Where's the directrix? This is the equation x is equal to negative p, or in this case, negative 6. 1, 2, 3, 4, 5, 6. So I'm not going to have a perfect sketch here, but I know the parabola has to open like this. The focus is contained in the part of the parabola that opens up in this direction. So which way does the graph open? I'd say it opens to the right. So the trick here was to first identify that I have x and a y squared. That means we're opening up in the x direction. From there, I wanted to figure out the value of p, which I determined was 6, and I immediately got the focus and the directrix after that. So same idea for example 2. I want to find the focus and directrix of this parabola. Now this time I see it's a y is equaling an x squared. So if I'm thinking about what the graph looks like, I know it's going to either open upwards or downward. So I'm thinking of, well, the graph is something like 4 times p times y is equal to x squared. Again, what is the value of p? I think what I'll do is look here, and instead of like jotting down the y part again, I could just say, well, I know 4p has to equal negative 8. And when I divide both sides by 4, I get that p is equal to negative 2. So this time the focus is on the y-axis, so it's going to be 0, negative 2. That's right here. For the directrix, it's going to be y is equal to positive 2. Altogether, I know that the parabola has to look like this. So this opens, I would say, down. The focus is here, and the directrix is here. Okay, going backwards here a little bit in example 3. This time, if we start with a focus and a directrix, can we get the standard form of the equation for the parabola? So if I try to sketch a graph of what's going on here, okay, so the directrix is at x is equal to negative 10. We'll say that's over here. And therefore, the focus has to be at positive 10, which is right here, 10, 0. So I know the parabola has to look like this. Therefore, the equation is something like 4 times p times x is equal to y squared. And I know this is going to be a positive value since it's opening to the right. In fact, the value of p is this number right here. It's equal to 10. So if you know the focus, it's like you almost immediately know what the value for p is. If I plug this into the equation, 4 times 10 times x is equal to y squared, I'll simply write this as 40x is equal to y squared. And this is the equation that we are looking for. All right, same idea in example 4. I want to find the equation of a parabola that satisfies these two conditions, a focus of 0, negative 14, and a directrix of y is equal to positive 14. So if I'm thinking about what the graph looks like, okay, I know the focus is down here. So this is 0, comma, negative 14. And the directrix is up here. This is y is equal to positive 14. So here the parabola is opening downward like that. So my equation has to be 4 times p times y is equal to x squared. And here p has to be a negative number. In fact, we can almost instantly identify it as this number here. If I put this into the equation, we have 4 times negative 14 times y is equal to x squared. If we simplify this, 4 times negative 14 is negative 56. Y is equal to x squared, and this is the standard form of the parabola. For the last problem in example 5, I want to find the vertex, focus, and directrix of this parabola. This is different. I'm seeing there's like this +1 and this -4, and I know that's going to affect the graph in some kind of way, where I don't think the vertex is going to be at 0, 0 anymore because we're moving it around. But these values actually tell you how to move the equation. For starters, if we don't focus on this 1 or that -4, I'm noticing the equation is more of the form, it's a y squared is equal to a 4 times p times x, right? The squared is on the y part, and the x is to the first power. So I know this thing is either opening to the right or to the left. Since the value here, 8, is positive, I know this thing is opening to the right. So it's going to open, I'll just put right as a note here. So let's try to make this thing look a little bit more like this, so I at least could identify the value of p. If I focus on the number 8, I know that 4p should be equal to 8, and therefore p is equal to 2. This number tells you how to find the focus and the directrix, but that's only if the vertex is at the point 0, 0. Like if the vertex were at 0, 0, the focus would be at 2, 0, and the directrix would be the line at -2, this vertical line here. But since the vertex is in a different spot, wherever it is, you'll go 2 in both directions from the vertex. So where is the vertex? It's the number, or it's the point, I should say, that when you plug it into this equation, you get 0 on the left and 0 on the right, making this a true statement. If I look here, if y is equal to -1 and x is equal to 4, you get 0, 0. So when looking for the vertex, for this problem, I know it's going to be at 4 for the x value and -1 for the y value. Because when you substitute those numbers here for x and this -1 for y, you'll have 0 is equal to 0, which is essentially this point on your parabola. So let's graph that. Okay, so 4 for x and -1 for y. That's right here. Now, the focus is going to be 2 points in this direction. So this is the focus. And the directrix is going to be, well, we go 2 in this direction, but it's really a vertical line. So I'll draw that in here like this. I know this equation is x is equal to 2. So this is the directrix. And this focus is at 6, -1. So I'll put that down here. The focus is at 6, -1. So I can't just use this number immediately to figure out these two things. I have to first locate the vertex and then go 2 in both directions from it. If you're trying to sketch a graph of this thing, I know it's kind of hard to do it by hand by using this directrix and this focus. I know it opens like this. What I'm going to do is just try to locate one more point on this parabola and do my best to sketch in what I think the graph looks like. So how would I figure out another point on the graph of this parabola? So I'm going to jot down the equation again. The equation was y plus 1 squared is equal to 8 times x minus 4. We just need some x and y coordinate that make this thing a true statement. I think what I'll do is I'm going to put a number in place of y. So this entire side is divisible by 8. Like if this side, if I can evenly divide 8 into it, then I can divide 8 to the side and easily solve for x. So I'm thinking that if I put 3 in place of this y, 3 plus 1 is 4, and if I square 4, I get 16, and 8 divides into 16. So I'm going to choose my y value to be equal to 3, and then try to solve for the corresponding x value for this y value. Let's see if we can do that. So if I plug in 3, you get 3 plus 1 squared is equal to 8 times x minus 4. As we just discussed, the left side is really 16 is equal to 8 times x minus 4. You can divide 8 to both sides, so you get 2 is equal to just x minus 4. And if you add 4 to both sides, you get that x is equal to 6. This means a second point on the equation is 6 for x and 3 for y. So that is 6 comma 3. That's this point right here. So 6 comma 3. So that's a distance of 1, 2, 3, 4 away from this focus, which means, there has to be symmetry here. You're also going to go a distance of 1, 2, 3, 4 down here if you want to get another point on this side of the graph. But once we have all of this, the parabola looks like this. It goes through those 2 points. And, it's a decent sketch of this graph. And that's it for this problem.